Hi dear friends, welcome to Chem Time with Manasa. Friends, actually my channel is all about chemistry. Through this channel, I am uploading the videos in which I am explaining different aspects and different concepts of chemistry. Since 2nd PUC or class 12 examinations are very near, I am uploading the videos which are very helpful for them. Today, I am here with an important chapter of class 12 syllabus, that is Chemical Kinetics. This chapter is very important because for CBSE students, this chapter carries 5 marks, and for Karnataka PU board students, this chapter carries 8 marks. Some students have doubts like for 3 marks, how much should I write? Or for 2 marks, how should I reduce the answer? So for those doubts, I think this video is very helpful to you. By studying the old question papers and the class 12 syllabus, I make a list of important topics from this chapter. So let us look at the list. So definitions for 1 mark or 2 mark, these definitions may be asked. Rate of reaction, rate law, definition of elementary and complex reaction, order and molecularity of a reaction, collision frequency, effective collisions, pseudo first order reaction, and units of rate constants. Then, in case of 3 marks, the derivations may be asked. In case of derivations, this chapter Chemical Kinetics has 4 important derivations. Derivation of integrated rate law expression and equation of half-life period for zero order and first order reaction. Then, effect of temperature and catalyst and collision theory. Let me explain all these topics one by one. Dear friends, from Chemical Kinetics chapter, in case of 2 marks question, one frequently asked and important question is, write the differences between order and molecularity of a reaction. In case of differences, first let us consider the definitions of order and molecularity. Order of a reaction is the sum of powers of concentration of reactants in rate law expression, whereas molecularity is defined as the number of reacting species involved in an elementary reaction which must collide simultaneously to bring about a chemical reaction. So order and molecularity. You may ask to write the definitions of order and molecularity for 1 mark question. Then next difference, order is always an experimental quantity but molecularity is theoretical quantity. Third difference, order can be an integer, it can be 0 and it can be even a fraction. But molecularity is always an integer. That means molecularity cannot be 0 or non-integer. Order is applicable to both elementary and complex reaction, whereas molecularity is applicable only for elementary reaction. So these are the main 4 differences between order and molecularity. Friends, first let us consider the definition of rate of a reaction. Rate of a reaction is the change in the concentration of reactant or product in unit time. That is, the rate of increase in the concentration of the product or rate of decrease in the concentration of any one of the reactant. So next one, the rate law or rate law expression. It is the expression in which reaction rate is given in terms of the concentration of the reactants, with each term rise to some power which may or may not be equal to their stoichiometric coefficient in balanced chemical equation. For example, consider a general reaction AA plus BB gives CC plus DD, where small a, b, c, d are stoichiometric coefficient of the constituents A, B, C, D. Here, rate equation is rate is proportional to concentration of A to the power x into concentration of B to the power y. Any quantity, any reactant or product written in a square bracket means that term indicates the concentration of that constituent. So concentration of A and concentration of B. Here the powers X and Y are different from the stoichiometric coefficient in the balanced chemical equation. So same may or may not be same. X and Y may be equal to A and B or may not be. Then minus dr by dt is equal to K into concentration of A to the power X and concentration of B to the power Y. This is differential rate equation for this reaction. Here K is rate constant of that reaction. So friends, next definition, a definition of elementary reactions. The reactions taking place in only one step are called elementary reactions, whereas the sequence of reactions giving products are called complex reactions. Next, collision frequency. The number of collisions per second per unit volume of the reaction mixture is called collision frequency and it is indicated by Z. Then effective collisions. The collisions in which molecules collide with sufficient kinetic energy and proper orientation to form the products are called effective collisions. Dear students, one of definite questions asked in your examination is derive an expression for rate constant of zero order reaction or derive integrated rate law expression for zero order reaction. So let us consider the derivation. Let us consider a reaction R gives P of zero order reaction. Rate of this reaction is equal to minus dr by dt. That is, decrease in the concentration of R with respect to time is equal to rate constant K into concentration of the reactant to the power 0, because it is zero order reaction. Any quantity raised to the power 0 is equal to unity. So minus dr by dt is equal to K. On rearrangement we get dr is equal to minus K dt. Integrating both sides of this equation, we get concentration of R is equal to minus Kt plus I, where I is constant of integration. At t is equal to 0, concentration of R is equal to R naught. Let us consider the initial condition. At t is equal to 0, concentration of R is equal to R naught, where R naught is initial concentration of the reactant. Substituting this, that is initial condition, in equation number 1, we get R naught is equal to minus K into 0 plus I. That is, R naught is equal to I. Substituting the value of I in equation number 1, we get concentration of R is equal to minus Kt plus R naught, because I is equal to initial concentration R naught. Rearranging this equation, we get K is equal to R naught minus R by T, or initial concentration minus concentration of the reactant at a time T divided by time T. This is expression for rate constant of a zero order reaction. We can compare this equation R is equal to minus Kt plus R naught with slope intercept form of the straight line, and we get a straight line having the slope is equal to rate constant K and an intercept equal to initial concentration. Very easy but guaranteed derivation from this chapter. Dear friends, this is another important and frequently asked derivation, which is derivation of integrated rate expression for first order reaction. To derive this equation, we have to consider a first order reaction R gives P. Let us write rate of this reaction, that is minus dr by dt is equal to rate constant K into concentration of R to the power 1. On rearrangement, we get dr by R is equal to minus K dt. dr by concentration of R is equal to minus k dt. Integrating this equation, we get ln R is equal to minus kt plus I, where I is constant of integration, and let us number this equation as equation number 1. Because integration of dr by R is equal to ln R, we get this equation. Then let us consider the initial condition. At t is equal to 0, concentration of R is equal to R naught, where R naught initial concentration of the reactant. Substituting this initial condition in equation number 1, we get ln R naught is equal to minus k into 0 plus integration constant I. Ln R naught is equal to I. By applying the initial condition, we get the value of constant of integration I. Substituting the value of I in equation number 1, we get ln R is equal to minus kt plus ln R naught. Kt is equal to ln R naught minus ln R. On rearrangement, we get k is equal to 1 by t ln R naught by R. That is, rate constant k is equal to 1 divided by time into ln initial concentration divided by concentration of the reactant at time t, or k is equal to 2.303 divided by t into log R naught by R. This is the expression for rate constant of the first order reaction. Here you have to remember two formulas or two basic concepts, that is ln A minus ln B is equal to ln A by B, which is applied in this step, and ln A is equal to 2.303 into log A, which is applied in this step. Friends, from Chemical Kinetics chapter, another important concept is half-life period. Half-life period means the time in which concentration of the reactant is reduced to half of its initial concentration is nothing but half-life period of that reaction, and it is denoted as T half. You have half-life period for zero order and first order reaction in your syllabus. So let us consider zero order reaction. We know that for this reaction, rate constant is given by R naught minus R divided by T. Let us number this equation as equation number 1. At T half, concentration of R is equal to R naught by 2. That is, at T half, half-life period, concentration of the reactant is equal to half of its initial concentration R naught. Then equation 1 becomes K is equal to R naught minus R naught by 2 divided by T half. In the place of T, we are substituting T half, and in place of concentration of R, half of its initial concentration. Then K is equal to R naught by 2 into T half, or T half is equal to R naught divided by 2K. This is equation of the half-life period of zero order reaction. Similarly, for first order reaction, we know that rate constant is given by K is equal to 2.303 by T into log R naught by R. At T is equal to T half, R is equal to R naught by 2. Therefore, K is equal to 2.303 by T half into log R naught divided by R naught by 2. T half is equal to, on rearrangement and simplification, T half is equal to 2.303 by K into log 2. R naught gets cancelled out. Then T half is equal to 2.303 by K into 0.301, because log 2 is equal to 0.301. Then T half is equal to 0.693 by K. This is the equation of half-life period of the first order reaction. But dear friends, these derivations are asked in two different ways. Either they are asked directly the derivation of the half-life period for zero order or first order reaction, or for zero order reaction show that the half-life period of zero order reaction is directly proportional to initial concentration of the reactant. Similarly, for first order reaction, the question may ask in that way, show that for first order reaction, half-life period is independent of the initial concentration, because in T-half equation of T-half, there is no R naught term. So, you have to prepare these two equations. The question may in two different ways. Friends, in case of 1 mark question, you may be asked to write the unit of rate constant of different types of reaction. In that case, this table is very helpful for you. For zero order reaction, unit for rate constant is mole per liter per second. For first order reaction, unit of rate constant is per second, and for second order reaction it is per mole liter per second. Then, in case of 3 marks question, you may be asked to explain the effect of catalyst on activation energy. So, before explaining that, let us consider what is a catalyst. A catalyst is a substance which increases the rate of reaction without itself undergoing any permanent chemical change. While explaining this effect, you have to put this graph of potential energy versus reaction coordinate. It is believed that a catalyst provides an alternate pathway by reducing the activation energy between reactant and products, and hence lowering the potential energy barrier. So let us consider this graph. This curve explains the reaction pathway of the reaction in without catalyst, in the absence of the catalyst. But in case of in the presence of catalyst, the activation energy between the reactants and products is lower. So the dotted curve explains the reaction pathway with catalyst. So next important aspect is pseudo first order reaction, which may ask for 2 mark. The pseudo first order reaction, a reaction of higher order which behaves as a first order reaction because of the presence of any one of the reactant in excess quantity, or simply one of the reactants is solvent. So example for this reaction is acid hydrolysis of ethyl acetate. So friends, then effect of temperature on rate constant. It is found that for a chemical reaction with the rise in the temperature by 10 degrees Celsius or 10 Kelvin, the rate constant is nearly doubled. So on this topic, they may be asked any 1 mark problems also. Then last concept, collision theory. So while explaining the collision theory, you have to mention 2 important terms, threshold energy and the proper orientation. The collisions of the molecules which collide with the minimum sufficient energy called threshold energy and the proper orientation are the reasons for the formation of the products. Friends, from this chapter, Chemical Kinetics, some of numericals may be asked. Very soon I am uploading the videos with numericals of Chemical Kinetics. If you have any doubts in this topics or any problems in the solving the numericals, please put them in the comment section, so that in next videos I will try to explain or give answer to your doubts. Students, I am uploading the videos of different chapters from class 12 syllabus very soon. Please support and subscribe my channel. I hope this video is very helpful to you. Thank you.